Hey guys, welcome back to my channel. Today we are going to talk about the NAT protocol, which is Network Address Translation Protocol. So in my earlier videos, you would have seen that we spoke about the local area network. We have spoken about the VLANs. So all of these concepts are based on private networks. In private networks, we always use private IP addresses. But what if we want to communicate with someone on the internet? Once the packet leaves your private network, it has to go on the internet, and the internet only recognizes public IP addresses. Because let's say I want to communicate with a friend of mine who is in another private network, and it is possible that both of us have the same IP addresses. Let's say my IP is a private IP of 10.0.0.1. It is possible that the other person also sitting in a private network with the same IP address of 10.0.0.1, right? But there has to be a public IP address on the internet such that I am able to communicate with the other person with a different IP address, right? Because we both need to be distinguished properly. Otherwise, our traffic would merge. I will be receiving his traffic, he'll be receiving my traffic. So here comes the concept of NAT protocol. So in every local area network, there is a gateway router. A gateway router is basically an interface between the local area network and the internet. Okay, in order to reach the internet, every device on the local area network has to go through the gateway. So generally what happens is whenever you bring up your topology, your network, you always configure a local route, you configure a default or static route saying that, in order to reach the IP address on the internet, you have to go through the gateway. So let's see in this example over here, we have PC1 with the IP address of 10.0.0.1, we have PC2 with the IP address of 10.0.0.2, and we have PC3 with the IP address of 10.0.0.3. Okay, all of these are part of a LAN, right, local area network, and we have a switch A which is connected to the router called gateway router. Okay, this is my gateway router. Okay, now what do we do over here? What does the gateway router do? Gateway router is basically interface between the internet and the local area network. So on the gateway router, which the interface facing the public internet will have a public IP address. Okay, let's say my public IP address is 61.120.10.1. Okay, that's my public IP address. Now all the devices in my LAN, PC1, PC2, PC3, will use this particular public IP address 61.120.10.1 to communicate with anyone on the internet. Now, how does this work? Okay, so let's say PC1 is trying to communicate with someone over here. Let's say this is a router with an IP address of 131.21.21.1. Okay, and so this would be my destination, and if my PC1 wants to communicate with 131.21.21.1, my packet will be forwarded to the gateway router. Okay, gateway router will see that it has network address translation configured. It will see the private IP address of the PC1 10.0.0.1, and let's say there's an application which is sending this particular an application which is trying to reach this particular destination. So that application would have a port. Okay, it would have a port number. So let's say I receive the packet on the gateway router with 10.0.0.1 and with the port as 8831. Okay, now the network address translation protocol will have a network address translation table. Okay, now this table is basically a mapping of IP private IP address with the port number to the public IP address and the port number. Okay, so what we will do is we'll swap this. Okay, we'll swap this with the public IP address now, which will be 61.120.10.1, and we'll try using the same port 8831. Okay, 8831. If 8831 is not available, then we'll use 8832 or some other port, whichever is available. Now let's say PC2 also wants to communicate with 131.21.21.1, and the same application wants to communicate. So it will be what 10.0.0.2 with 8831, and this would be 61.120.10.1. But now since 8831 is not there, we'll be using 8832, okay, or the next available port. So this is how the network address translation works for the outgoing traffic, right? Again, for the incoming traffic, let's say 131.21.21.1 receives the traffic and it sends back the response. The response is received on the gateway router over here in this direction, right? And now we'll see that it is coming with the IP of 61.120.10.1 with 8831, and we will see that in the network address translation table, right? So this is the table. We have two columns over here, one with the private IP and one with the public IP. We'll see that this is mapped to this particular IP address 10.0.0.1.8831. So this has to go to PC1. So then the gateway router will send this packet out on the switch towards the PC1 with the port number 8831. So the application 8831 receives it. So this is called as port address translation as well. Okay, we are using the port number to identify, and this is how it is done. Now there are two other types of network address translation called as dynamic and static. Now sometimes what happens is we have a pool of public IP addresses. Instead of just having one, let's say I have 61.120.10.100. Okay, I have 100 public IP addresses. Now every time someone wants to go out, we'll use, so over here 10.0.0.1 will be mapped to 61.120.10.1, but 10.0.0.2 will be mapped to 61.120.10.2. okay, then third PC 10.0.0.3 will be mapped to 61.120.102.10.3. okay, like that we'll be using multiple it will dynamically assign a public IP address to the private IP address. Okay, so that is called dynamic NAT. And then there is static NAT, where you can manually log on to the router and configure and populate the routing table with a particular IP address, saying that 10.0.0.1.8831 port number should always be mapped to a particular IP called 61.120.10.15, let's say, for example. Okay, I'll give it in the command line and I'll populate this routing table with that command line. So that is another way of configuring your NAT address, network address translation table. So, but the static and dynamic, we are using multiple public IP addresses, which is not cost effective. It is expensive to have multiple IP addresses to maintain them, and also you're exhausting those many IPs, right? Instead, just use one and all your hosts in the local area network will be able to communicate without any problem because of the port address translation, right? So one thing is we are saving up on public IP addresses. Second thing is the internet, when the packet is out on the internet, it does not know the actual host's IP address. So that is secure. So this network address translation helps in keeping your data secure. It also helps in not exhausting the IP addresses. So this is generally run on the gateway router, the NAT network address translation protocol, and it's basically mapping private to public and also public to private IP addresses. I hope this made sense. If you guys have any questions, please do let me know in the comment section. Please like, share and subscribe, guys. Thank you.